Welcome you all to this Cryo-EM course, and initially I told that okay, we are going to discuss about the image formation. Last class we discussed about how sine wave propagates through the medium, and then how we can correlate those things with the wavelength and the phase difference, and we deal with only one single wave and how this one single wave moves in that medium. It may be the air or it may be the vacuum, how they are propagate. So, now we also learn that what is called the amplitude, what is called the phase, and what is the phase difference, and how if we want to draw these things in a phasor diagram how we can draw that, and that is basically we are representing the angle. Right. Now, in today's class we are going to talk little bit more about how if there is a two waves, what is going to happen, how they are interacting. For last class I discussed about that one, that it is very important that when there is a one electron or one photon cannot give you an image. So, there are multiple photons or electrons are coming, and there are, when there is a multiple photons and electrons are coming, there is a different types of possibilities are there. So, we will start with only one or two waves together, that how they are interacting and what kind of information we are getting from there, what is the amplitude, what is the phase difference, how they are interacting. So, then we will discuss about that, the image formation. Let us take a look. So, in last class I showed you that okay, there is a waves are going like that. It is a very simple way, there is nothing complicated, only one single wave, and then when wave will propagate, there will be a change like that, and there will be a change like that. So, wave will move, and when one single wave will move, you can consider that okay, if this is your wave 1, this is the position of your wave 1, then wave 2, then wave 3. Now, most of the time you can consider that the wave 1 will started moving, and then wave 1 will disappear, and then your wave wave 2 will be there, then final stage wave 2 will disappear, only wave 3 will be there, and you can see the difference here, the phase difference here. So, initial one started from here, and then second one is started from here, and third one is starting from here. Okay, this is very normal one wave, how they are moving. Now, let us take a look, if there is a two waves and there is a superposition between, they are overlap with each other or they are just superposition with each other, how they are behaving. So, first wave I am drawing here, that okay, I have two wave, this is my x axis, this is my y axis. As I mentioned, this will be the amplitude, plus amplitude, and this will be the minus amplitude, and also we can consider that this is our spatial frequency that we are denote by k. So, spatial frequency, based on that we are plotting that. So, here this will be the k x, then spatial frequency, and now we have one wave like this and another wave is like this. There is a two waves coming. So, this is one wave, wave 1, and this is the wave 2. So, what is happening, you can see there is a one wave is going that, and then simultaneously there is a other wave, but the start point is different, and the amplitude, if we just look at this one, that amplitude is also different, their start point is different and the amplitude is also different, they are not same. So, now if we just consider that your wave 1, so some value we have to consider that okay, so it will be 0.9 sin kx plus 1, and then wave 2 we will just consider 1 sin kx. Why it is kx? Because this particular wave is starting from almost 0. So, that is why I am representing these things like that, and the amplitude, this amplitude we are considering 0.09 and this amplitude we are considering 1. Now, when there is this kind of waves are there and we have to add them together. Mathematically, if we want to add them, yeah, definitely we can add both the waves together and we will get a huge mathematical derivation. We are not going to that part because that is not the topic of this particular course. So, we just want to get a clear idea what is happening when there is two waves are propagating in same direction and they are almost in a same phase, what will happen. So, the result will be, if there is a two wave and when we are looking at this two wave, there will be some kind of changes in the amplitude and the position of this two wave. So, it will come like that. So, what is this? So, here we have two wave 1 and wave 2. So, basically this is basically wave 1 and wave 2 sum, and that is giving us a resultant wave, and that is called this wave R. So, this is our resultant wave. Okay. So, that resultant wave means summation of these two. Now, as we discussed, we are not going to go to the mathematical details, we will just use this kind of pattern and try to explain those things, how we are this addition or subtraction it is happening, or sometime we will use a phasor diagram also, because phasor diagram sometime this phasor diagram it will help to represent the phase in a proper way, and then we can get the resultant wave. Okay. What is next? Now, in the same principle we are going many other wave and then see what kind of image you will get. So, this is another wave. Now, I have a second wave which is coming in the same position here. There is no phase difference, only there is an amplitude difference. Okay. So, here the black one is the wave 1 and the blue one is the wave 2. When we have this kind of two waves and when they merge together, because you can see both of them are in the same phase, there is no phase difference, both the waves are almost same, and the only difference is that amplitude is changing. So, here also you can see the amplitude is changing, right. In this particular situation, we have to add both the waves together and we will get a resultant wave where it will be in the same position, amplitude will be in same position because there is no phase difference between these two waves, and amplitude will be much higher than both the waves, wave 1 and wave 2. Okay. This much it is clear. Then what about there is a opposite scenario? That means that okay, two waves are completely in opposite direction, and how they are going to behave if there is a two waves are coming in a completely opposite scenario. So, that we want to draw it here and we want to figure it out how we can represent that wave. So, we will go to the next one. So, as I mentioned that okay. So, there is a so we will just use this one same way, we will draw that wave again. So, one wave I am drawing this one. Okay. So, this is again our amplitude and this is the phase. Now, consider that the second wave is going like this. Then you can see the start point is 0 for both the waves, but one wave propagates in this direction where we are starting 0, then it will be lambda by 4, then lambda by 2, then 3 lambda by 2, and then complete lambda. So, here you can see this is the same thing, but this is appearing in a negative, okay, minus lambda by 4, right. So, this one is also coming minus 3 lambda by 4. So, this one is the black one, where black one it is coming. So, it will be better to use this one. So, where we have a minus 3 lambda minus 3 lambda by 4, where this one is coming 3 lambda by 4. So, you can see there is a major difference is this sign, right. This will be the positive and other one is the negative. So, now if we want to merge these two wave together, what will be the resultant wave? So, there again if we just consider this is wave 1 and this is wave 2, our resultant wave will use it like that, wave 1 plus wave 2, and the resultant wave we can represent it like that. So, we have this two wave. It will be better to draw this entire thing one more time, then it will be easier. So, now the resultant wave it will come like that. So, what is changing here? So, you can see this resultant wave is also started from the 0, but the major change is that here if you have the amplitude this one, if we just consider lambda by 4, again the lambda by 4, both the cases if this one is plus a, this one will be the minus a, and that is basically neutralizing each other, and we are getting a wave which has a no amplitude or almost close to 0 amplitude. So, if these two wave, what is the major difference when I am talking about the minus sign, that okay, minus lambda by 4 or plus lambda by 4, there is a phase difference, they are not in phase at all. So, one wave is going in this particular phase, other wave is completely in a different phase. When we are discussing that how wave propagates, so if you recall that last class, what I did, I told when t equals to 0, you will get an wave like that. Now, if you move on, so then when t equals to capital T by 8 or capital T by 4 and then capital T by 2, in a certain point your wave is almost opposite to each other, and if you put it in a phasor diagram, initially this one it is coming in this particular direction, but in this particular case if you just consider, you will get it like that, okay, your actual wave, that red wave, if I just use that red wave, this is direction is this, on the other way that when wave propagates it is just appearing completely opposite. So, they are in a different phase, and when they are going to merge together, they will just neutralize both the waves and it will appear is almost 0. So, this is how we add the two waves. So, this is the start point. Someone can ask again that how it is going to help us, because here now we are talking about the two waves, how these two waves are interacting with each other. If there is a two waves and interact, here we learn that one, that okay, when these two waves are in a same phase. So, if they are in a same phase, we can see the amplitude is increasing and we can see the bigger amplitude. If there is even a smaller amplitude, any wave is there, or we cannot see that two small wave are small wave propagates in this x direction, we can see only that resultant wave. So, same example again, if we are standing in front of a sea beach, multiple small waves are coming. If there is no big wave, we can see only the small wave, that multiple waves are coming. Or in front of a pond or lake, we just throw a stone, what will happen? There will be a ripple, that wave will go and go to a. So, now if we do not throw multiple stone at same time, there will be only one ripple and it will go spread in a very nice way. Now, if there is a two stone, we are taking it and throw it in same time, or whenever we are thinking that we are throwing it in same time, it cannot go in the same time, one can go little bit, there is a phase difference when you are throwing that stone, and then there will be a wave. So, sometime these waves are coming together and they just converge with each other, and there will be, they are in a same phase. So, if this wave is going in this direction, this wave is going this direction, but they are in the same phase. When they will merge together, you can see their amplitude is higher. So, same thing in front of the sea beach also, you can see two waves are merging together. So, they have a larger amplitude. On the other hand, if the wave propagates in this direction and the other wave is going in this direction, what will happen? There is a amplitude difference between these two, there is a phase difference. So, they will just normalize each other. So, you can see a small wave is going. So, when there is a constructive interference, this is called the constructive interference when it is increasing their amplitude. So, this constructive interference basically helping us boosting the amplitude. When it is boosting the amplitude, we can see that bigger amplitude wave, the smaller wave will be there, it will be not visible. Okay. So, from this we will start discussing that okay, if there is a multiple waves are coming together now, what kind of information we will get it from there. So, let us start a look here. So, first thing first, I will draw a wave here. So, first as I draw it previously, this is the wave it is going. Okay. So, now this is the next wave. Now, this is the third wave. Now, if I just want again with the fourth wave. Okay. So, now you can see there is a continuously wave is moving in one direction, and if you want to converge all of them together, what you can get it, that okay, you can get something, this kind of wave. So, when there is a, this is, if we just consider at the initial stage, even there is a phase difference, they are not going to affect so much at this particular point. But if you go further in this direction, if the wave propagates in x direction, and if you go further, it is going to affect each other, something like that. So, now the first one you can see they are very much similar, all the waves are coming together and you will get a higher amplitude. But if you go further and further, you can see after a certain time they will just opposite with each other, and that is going to affect your amplitude. So, we will discuss these things more in the next slide. Now, first thing we just let us consider one small thing, that is whenever we have to discuss about the phase, we want to plot those things using the organ diagram, and we will just give a very simple idea how we can represent those waves. So, here the one new term it is coming, that is complex number. Many of you learned these things during your class 12 12th standard study that what is complex number. We will just recall that. So, in that complex number there will be a two part, one is the real part and one is imaginary part. So, if I just say that okay, z is a complex number, how we can represent that will be x plus I y. So, here x is a real number, x and y is a real number where I is an imaginary number. Okay. So, here I we can represent I is an imaginary number and I is this. So, we want to represent this complex number. So, this is easier to explain the phase, how we can represent the phase of any wave when it propagates through a any media. So, here we want to represent this complex number in a polar coordinate. So, polar coordinate means r and theta. Okay. So, we want to represent that in a polar coordinate. So, when we are considering any wave, so here we can say that this is the real coordinate and this is our imaginary coordinate, as I mentioned earlier. This is our imaginary coordinate, right. So, now here if this is the vector, I have to plot it. We can plot it that okay, this is x plus I y. So, this is our z, and if this is the angle theta, we have to represent these things using a polar coordinate, right. So, how we can represent these things that okay. So, here we can say that we are not going to in details derivation how we can get all of these things, how we can convert each other. Just try to understand that okay, y axis here, y axis we are taking it as a imaginary coordinate where we are plotting that I related term, and this is the real x axis is the real axis where we will plot the x. Now, x and y we want to convert, when we are talking about any wave we want to plot it in a phasor diagram, right. We are plotting it like that, this is a phasor diagram. So, what is this? This one we are telling amplitude. Here this particular value we will represent as r, and then the angle we want to plot it based on that angle, what angle. So, that is the reason here if this vector is going through this x axis, probably this theta will be 0. Now, we are plotting this vector in such a way that we are considering this angle is theta. Now, we want to replace this x and y using the polar coordinate. So, in this particular case again this will be our imaginary coordinate and this will be our real, and then if we have the same this vector, as I mentioned, this is the amplitude previously we mentioned. Here we are representing these things as r. So, this is the amplitude here, right. This is the, so here we are representing this as a r. Now, if we just draw a line here, if this angle is theta, this will be r sin theta and this will be r cos. Okay. So, this is from the trigonometry we know that, right. If this is r and this theta, it will be r sin theta, this one, and this will be the r cos theta. Just let me write this clearly. This will be the cos theta. Okay. So, again this will be the y axis will be the imaginary line and this x axis will be the real coordinate. Now, if we go to the next page, now if we want to represent x minus I y, how do we represent these things? Again it will be better to draw this coordinate, this will be our imaginary line and this will be our real. Now it is coming in the negative side. So, our vector diagram, it will come like that. This will be our theta and this will be our x minus yi. Okay. Now, if we want to represent these things just like a wave that we already discussed, right, that okay, sine a sine omega t, or if we just consider that f of x equals to a sine omega t plus theta, okay, where theta is the phase difference. So, if we consider this one, that we will just consider a simple one, that a sine omega t. How we can represent these things? So, we will represent these things like that. So, its amplitude we have to represent as well as your imaginary line and your real line. So, this one we already represented couple of times, that okay, this one is a sine omega t. So, if we just draw this one, if this is the value, if this will come. So, based on that, if you just remember that previous one, that r sine omega t or r cos omega t, we can represent it same way, that omega t or a cos omega t. Okay. Now, here from where we started, this is a complex number z. So, z means we are telling x plus I y, where x and y is real, I is the imaginary component. Now, we already noticed that okay, if we have that any angle theta, right. So, if this is x plus I y and then if this is r, we can tell that it will be r, it will be r sin theta and this will be r cos theta, right. So, here we are representing these things that using a polar coordinates, how we can. So, if we just replace x equals to r cos theta plus y is the imaginary line, where the imaginary term it will come here, the y axis. So, it will be I r sin theta. Okay. Now, from the Euler formula, you just remember that we are not going for this derivation, that how this Euler formula we can prove that one, because that is not our goal of that course. So, from the Euler formula, what we can say, I theta equals to e to the power I theta equals to cos theta plus I sin theta. Now, same way the other part is also true. If it is I theta minus I theta, how we can write it? It will be cos theta minus I sin theta, right. Now, this will really help us, because finally we just want to get the cos theta or sin theta values, how we can get it. So, if we want cos theta, what we have to do? We have to e I theta plus e minus I theta by 2, or if we want sin theta, what I can do? I will just use the different sign, I theta minus e to the power minus I theta by 2. And if this is true, we can get the angle also, that tan theta, you will just divide sin theta by cos theta, divide by this, you will get this mention also. So, from this you can convert that okay, if there is any normal function that. So, generally imaginary term, we are using this imaginary term to explain the phase, because it is very difficult to know the phase. Amplitude, I am talking about amplitude, we can calculate easily. So, if you are standing in front of a sea beach and there is a multiple waves are coming, if there is a very huge amplitude of any wave, you can see that you can see only the amplitude, small waves will be not visible at all, because you have a small wave, multiple waves are coming and then there is a huge wave one it is coming, which is going to suppress all the small wave. So, what we are looking from there, when we are standing in front of a sea, we can see a huge amplitude of that wave, but it is a very difficult task to know the phase. So, that is the reason phase we are applying as a imaginary term, and then we are trying to explain the mathematical derivation of the entire part. But here one important part is that okay, there is a wave that if we have a imaginary and real term, if this is my that is z equals to x plus I y. Now, we know that we can represent these things, that x plus I y equals to r cos theta plus r sin theta, which we can convert those angles and we can easily calculate those information, how we can represent. So, same wave we can represent it like that here, that if there is a one wave, if you just consider this is a wave, and we have to represent that is real component, that amplitude as well as the phase, that we can represent using this kind of diagram. So, if we want to represent these things, we can represent it like this will be r cos theta and r sin theta, and this will be imaginary and real. So, we can plot those information like that. Now, we will take these things in further to discuss how those waves are, when these waves are propagates, and how we can represent these things in a phasor diagram. Previously, we already discussed the similar kind of pattern, that when there is a wave and there is a v of, there is a velocity of that wave, and at the time 0 what will be the position, and then if we just gradually go increase the time, there will be a change of that wave. Now, here we are trying to show a wave propagates through the x axis. When waves propagates through the x axis, what kind of changes it is happening in their formula, and the phasor diagram, if you want to plot that one, how we can plot that wave. So, we will start here. Okay, the first wave it is going here, this will be minus a and this will be plus a. We know the amplitude, and then we can write it like that, a sin k x, this will be the k x, that x axis, the spatial frequency we are plotting. So, now we are want to plot this one. So, when angle equals to 0, we are plotting this wave in this direction. Now, same way, so there is a change in the phase. Okay, so now you can see start point, initially start point is this one, wave propagates, and that is why there is a change in this direction, and again this will be plus a and minus a, and we want to represent this wave here. What is the phase difference here? If we just consider that phase difference, we will write it like a sin k x, then plus pi by 3, and we want to represent these things in this diagram. So, in the later on it is going to help us. So, we have this. So, you can see that wave rotated here, and we can see this is pi by 3, right. Then next one, again there will be a change. So, this will be your up wave. So, again this will be plus A and this will be minus A, and we want to plot this one. Here you can see total 90-degree phase difference. So, in this particular wave, if we just consider, it will be sin kx plus pi by 2. Okay. So, now if we want to plot that one, how we are going to plot it? So, here you can see initially it was started here, now the wave is completely rotated here. So, now it is coming pi by 2. What about next? The next wave, you can see that here it reached the maxima and then going down, it reached to the maxima and going down. So, here you can see there is a almost 3 lambda by 4, it moved to this direction. Okay. So, now we want to plot the same one again. So, if we just consider, this will be a sin kx by plus 2 pi by 3, and that we want to plot it here. So, this is the diagram, and our wave it will be rotated like that. Now, where it will be completely half wavelength change. So, now in this case you can see initially this is 3 lambda by 4 wavelength change, but here it is a completely lambda by 2 phase difference. Now, if we want to write the equation, we can write it like that. There will be a difference that will be kx plus pi. Okay. So, here it is 2 pi by 3, here it is a completely half pi. So, here if we just consider what will be the position of this wave, if we just draw this diagram, it will be completely opposite. So, if there is a path length difference is lambda by 2, we can always see that there is a change, there is a phase difference, they will be not in phase. In rest of the cases there is a phase difference, but still they are in a same phase. But when there is a completely opposite lambda by 2 path length difference between this wave and this wave, if we just consider this is the wave and this is the wave, if we compare, you can see there is a always there is a opposite phase, they are in a opposite phase all the time. So, if there is a lambda by 2 path length difference, there will be opposite phase, but if there is a lambda phase difference, they will be in phase. So, I will stop it here today, and the next class we will discuss more about how we are getting the diffraction pattern and how we can generate images from there, and what is the difference between the diffraction pattern and the images. Thank you all for your attention.